Somebody was going to tell you that.
Okay. So thank you, Paul. And before I get started, why don't you just give me a time check so I have an idea of what we're working toward?
We're working towards
12:15.
12:15.
Okay, so we'll do the 12:15 version of this. So as Paul said, I guess it's not morning, so almost good afternoon. My name is Joe Mele, and I'm with Dialogic. And I think I had a topic that was a little abstract. So I've taken a little poetic license here with what I'm going to talk about, and hopefully there'll be some value here for you all. So before I get started, just a little bit about my team. I came to Dialogic about a year and a half ago via an acquisition of a little company that I had started called Open Media Labs, which was focused on video, advanced video technologies, video analytics, things like that. And our role in Dialogic is to help video enable the Dialogic platforms. And what we're doing is working on advanced, what I call at least, advanced video software to help improve quality and performance, as well as getting into video analytics, so looking at technologies that can help analyze the data in a video content stream, as well as manipulate the data within a video content stream. And back in February of this year, actually spoke at the 4WE conference. It was in Miami. And I was surprised that I was invited back after that, but I was, so here I am. But just wanted to hit on three of the takeaways that I had talked about then, because I think it can provide a good intro or segue into what I want to get into here. The first was, and what I had talked about was higher level video strategies and how they're impacted by the 4G environment. And the takeaways that I had was, one, in the 4G world, at least what I see, is that it will unleash a whole new generation of what I call advanced video applications. And the enablers there are things like, you can guess them, is the increased bandwidth, the fact that it's all IP, and the idea that the 4G network design is really designed around interactive multimedia applications to help enable those. So that's huge. And from our perspective, when we look at that, we say, so when you have all these capabilities, these applications that will get unleashed as a result of these capabilities, what we believe is that video will start becoming what I call the new voice, in that if you look at voice kinds of applications for IP communications, things that are voice-enabled today, we see becoming video-enabled. So you think about the very simple ones, the ones that we could all list off the top of our heads. So a voice call can become a video call, or a voice conference call can become a video conference call. Or a voice message could become a video message, or IVR could become IVVR. So things like that. But in essence, video enabling what we see today as the voice services, and having video become more of what I call the de facto standard for IP communications moving ahead. So when all that wonderful stuff happens, one of the things, and this is opinion, that we also believe needs to happen is that the content, the video content, needs to be trusted. And when I say that, I mean you need to have the assurances of what you're getting. So from a quality perspective, you'd like to have the assurance that the quality that you're getting in that video content will actually meet your end user's expectations. Or from an authentication perspective, you'd like to have the assurance that the content that you're looking at is authentic. It's not been tampered with. In most cases, at least, you'd like to also have the assurance that the content is not objectionable. And things like that. So in essence, having the assurance and the consistency of and the knowledge of what you're getting, and trying to take out a lot of the guesswork there. And so that's what we're calling making what I call video trusted. Now, what I want to focus on today, and this is really the segue, is one piece of that, and it's the quality side. It's understanding from a quality perspective with video, am I getting what my customers expect? And with in the 4G environment, what's going to change? Is that going to be a question? Is that going to be solved? That's really what I want to try to hit into. So I don't like standing by the microphone so much. So I may move around and get out of range of this. So if you guys can't hear me, just yell or throw something at me. No shoes, by the way. So the question here is, can 4G video quality be trusted? Do you have the assurance that from a customer perspective, whatever application or SLA or tier of service that they have, are they going to get what they're looking for? That's the question. And the question that we've looked at my team is, so in this 4G world, where you have these big pipes, where you're going from environments today where, let's say, you have a 3G through 24M type environment where, let's say, you have a total bit budget of 64 kilobits per second, and out of that you have maybe roughly 40 kilobits per second allocated to video. It's a constrained environment, and to try to manage video and get good quality video out of that is a difficult task. It can be done, but it's a difficult task. In these new environments where you can have speeds of up to 100 megabits per second, it helps, and it does help from a quality perspective. But the issue is there's more factors. I don't think that's good. The issue is there's more factors that go into video. Video is a complex beast, and there's more factors. So the pipes help, but the pipes don't tell the whole story. And, they don't solve the whole problem. And that's something that we looked at. So if you look at the question, say, can 4G video quality be trusted? The answer is no, because there's other factors. You have your network factors, and the gentleman talking before talked a little bit about this. With if you're over an RF network, you're going to have things like bandwidth fluctuation. You're going to be dealing with interference. You're going to be dealing with noise. That'll cause things like packet loss, delay, etc. So you have your network issues, but also you're going to have your compression issues. And even though we're talking about having these big pipes, you're still going to be compressing video data. And the reason being is, in my nomenclature, video is a bandwidth hog. It takes up a lot of bandwidth. And even on these big pipes, we're just going to still need to compress the video data in order to be efficient. And so that's something that's going to continue. Now what happens is anytime you compress the content or the data, two things are going to happen. One is you're always going to lose some portion of that data. There's going to be some loss that happens anytime you're doing compression. The other thing that may not always happen, but there's a good chance will happen, is also you may get some corruption of the bits of that data. So bad things happen when we're doing this, and it's something that can be expected. With someone who's building video software, it's the kind of thing that we try to mitigate, the kind of thing that we try to minimize, but it's there. We're getting into physics of it. And so it's always there. So anytime we compress the data, you're going to have some of those bad things happen. That can also be complicated when you think about, let's say, a video service. So let's say if we're doing a video streaming service, let's say from the network out to a handset. If you're in a peer-to-peer type environment, you're going to compress it one time, right? So it's not that big of a deal. But I think the reality is that's going to be rare. What's going to happen is you're probably going to be getting numerous handoffs as you go through the network. And with those handoffs, more likely than not, you'll have transcoding going on as you get from the original content out to that handset. Each time you do a transcode, you incur the same kind of issues that I talked about. You're going to lose data. There's a chance to get corrupted data as a result of that. And as you do the transcodes, what happens is it becomes cumulative. So if I'm doing it one time, I may take some kind of a hit once. If I'm doing it 5 times, I'm going to get that cumulative hit 5 times. So these are things that we need to deal with. And from a video perspective, unlike voice, I had done voice work way back when, voice is a little bit easier to manage. Video, there's other things that we need to look at. I'll talk a little bit more about that. So, in essence, what I'm saying is, from a video perspective, the pipes help, but there's still issues because there's other factors. And so what do you do? And if you look at what I'll call the current methodologies or models for how people are measuring or monitoring quality, let's say in a network environment, let's say voice over IP as an example, measuring and monitoring voice over IP. The model that's used today is typically what I'll call a QoS type model. And what I mean by that is measuring the health of the network as opposed to really looking at that specific service. And so what happens is you start looking at things like packet loss. You start looking at things like jitter and delay. And with that, you can get a pretty good indication of how that's going to impact the quality of service for that voice over IP application. So there's a nice correlation between looking at those what I'll call QoS type metrics, or network-based metrics, and the actual quality of that service or application. On the video side, it's different. It's a different beast. And the example that I would give is if you look at voice, let's say if I'm monitoring packet loss as an example, I could have, let's say, up to 1% packet loss on a voice service, and it's very tolerable. Actually, from a user perspective, you probably would not pick that up at all from a quality, from your own user quality of experience. If I take that same model and apply it to video, it's different. Because what happens is, it's not just about looking at the cumulative packet loss that you might have, but it gets into, so which packets, which bits am I losing? Where do those bits reside within a video frame? And even more, or in addition to that, and by the way, and which frames are they? Because if you think about video now, if you think about a frame, to simplify the situation, look at it as a picture, and you may be losing bits, and if those bits are on the edges or the outside or the background of that frame, it's something that you may not pick up from a perceptual perspective. But if those bits happen to be in a critical area within that frame, the impact of that bit loss could be significant. You can take that and further, amplify the situation from a quality perspective and say, and then what frames are we looking at? If I'm looking at what we call reference frames or iframes, which have all the data built in for that particular sequence, if I'm losing critical packets or bits that are critical to that picture within an iframe, it could be catastrophic. If I'm losing bits that might be on the edges of a predictive frame, let's say, it's no big deal. Chances are you wouldn't even notice it unless you were someone who had golden eyes that were trained to look at video content. So the point is, video's different, and it requires different means and methodologies in terms of, so how do I tell what that user experience looks like, or what does that quality look like? Because the methods that we use today, which are QoS-centric, although very effective in what I'll call voice over IP and managing data services, they don't necessarily correlate with really managing and assessing the quality of experience on the video side. So in essence, what we need is a different approach, different measures to look at. And at the highest level, what we need to do is we need to look at the content. And more importantly, we need to understand what is the end user saying. Because like I said, it's no longer a percentage of packet loss, but it's what bits where, which frame, that kind of thing. And so what we need to do is we actually need to look into the content, understand what the user is saying, and in my nomenclature, once again, what I call this is the end user perceptual video quality. In the industry, the term that's becoming more popular now is quality of experience for video. So let me talk a little bit more about what that is. So the kinds of things that are being measured, like I mentioned, the traditional measures, which are network-centric, which are really geared around measuring the health of the network, things like your delay and jitter and packet loss. That's how we're doing things today. When we look at video, like I said, it's not sufficient. We need a different set of measures. And this is not all inclusive here, but just some ideas of the kinds of things that you would look at. So you're looking at, is the content blurry? Am I experiencing blackout? Or are the frames freezing? Am I getting blockiness? Or am I getting macro blocking? Do I see artifacts within the video? Am I getting noise? What about the audio-video sync? Is lip sync working or not working? That's a big dissatisfier, by the way. But it's those kind of things that we're looking at. So it's a different set of metrics that we're looking at when we try to assess the quality of video as opposed to data services or voice services. So what I'm going to do is show you a very simple demonstration just to try to take what's probably something that's abstract and just make it more clear. And this is a very simple demo. And so I'll give you the disclaimer. So by no means am I measuring all the things that you saw in the previous chart. We have a subset here. But what I want to do was just give an example of how we're measuring the perceptual video quality in real time. And so what you'll see, and this will be the next slide, is on the left we have a YouTube video. And I'll warn you in advance, the quality is generally very bad. But we'll have the YouTube video, and on the right what we have is a scale. And what we're doing is measuring the quality of that video on the left in real time And so what you'll see as I show this is you'll pan back and forth and look at what you see on the video, and then look to the right and see how it's impacting the chart on the right. And not to get into the details of the chart, but just to give you a little bit, just to help as you look at this next slide. So what we're doing is we're measuring in real time. The scale there is 0 to 1. 0 is bad, 1 is good. And what we're doing is we're actually measuring it 1 time per second. So what I'll do is I'll play this out at 30 frames per second. So each time you see a data point go up on that chart, what's happening is it's taking the average score for the previous 30 frames or the previous second and putting it up there. So let's do this, and hopefully it'll work. And like I said, as you look at this, just kind of look back and forth. And the example is really just measuring what I'll call that perceptual video quality, or the quality of experience in real time. And the point, like I said, is as you see some of the blurriness, as you see some of the very fast panning, like you've seen there as an example, as you see some blockiness, you can actually see on the right-hand side how that's impacted on the measures. As you see things get temporarily better, by the way, you'll see that the actual scores go up. But there's not too much of that.
Can you turn on the audio?
There's no audio on this.
And how is it being measured? Like, is it, are you doing face recognition and doing background recognition?
No. What we have is we have some algorithms that are looking at things like blur and measuring that. We're looking at, in this case, we're actually looking at motion and fast motion or panning, that kind of thing. And we're actually looking at blocking. So we have algorithms that we've developed that are recognizing these things.
So you're about scoring the image?
Yeah, and we came up with our own score. So this is by no means any kind of an MOS type situation. We came up with our own score, and it was really just to show the demo, to show almost what I call the cause and effect between the two. And those are the parameters that we're looking at. So it's not that whole list that I had on the page before, but just a subset. Just show an example of some of the things we're looking at. Another question? Or?
At what point in the chain does the analyzation take place? So ultimately, are you looking at the user tablet, something running on the user's phone that actually can read the signal coming through, or from the carrier as it's being spit out?
So let me show you the next chart. That's a great question. So anyway, just a simple demo. And got a good question here. So let me give you an example, because once again, kind of going from the abstract to something a little bit more specific. And the question was, so how might this be used? And once again, what I have here is what I would characterize as a very simplistic use case, purposely so, just to make a couple points. So the example here would be, think about a streaming video service going onto a handset. And what we'd be doing is leveraging the kind of techniques that we talked before, so the algorithms that we're putting together. And by the way, as we do this, we're not doing, it's not a one-to-one where if I'm measuring 10 metrics, I have 10 algorithms. We're actually doing some tricks where we're minimizing the number of algorithms that are looking at some of the different things, and that's some of the secret sauce that we're trying to apply here. But if you look at this, so we're taking the video content from the server, going through the media server, over the wireless network out to a handset. And in this simple diagram, like I said, I left out a number of boxes here just to make it very simple. What we're doing is we have quality assessment agents, so those stars that you see there, in the different boxes. In the content server, you get the assessment of what the original content looks like. In the media server, you get an assessment of, gee, when I'm doing this transcode, what happens at this handoff point. And then having a lightweight agent within the handset that's also in real time doing assessment of that video quality. Now, on the handset side, what we're doing, and this is just for this example here, is taking that assessment, or maybe something similar to what you had seen before, and sending that back. So that in the network, in this case to the signaling server, so that we have an idea of what that quality looks like. And if it's not meeting those expectations, like I said, the expectations can range anywhere from great to just okay, depending on the type of service and the tier of service, all those kind of things. But sending that information back and providing real-time adjustments, recognizing, gee, the quality is not meeting expectations because it's blurry, and taking the necessary actions to try to improve that piece of it and doing that in real time. Now this, by the way, This example here is a picture of a prototype that we're actually building right now, and are planning to have this done by the end of the year. And so this is work in progress, but this is a very high-level representation of this. There's some boxes that I left out here, by the way, that's just to keep it simple, but just to show the idea that in real time, having agents within specific handoff points within the network, including the endpoint, recognizing what that end user quality looks like, sending back feedback, and making real-time adjustments. Yeah.
I understand that, like that star at the handset.
Yeah.
If you look at that versus the quality at the source, obviously, you could say the quality of experience, how it got degraded as it went through transcoding and over the network. But the previous demo that you were showing,
right.
What was it comparing? Like, what was the source and destination? Like?
Yeah. So the previous, and maybe I need to explain a little bit better, was really just to show cause and effect, that we're actually monitoring certain aspects of that video. We made up our own score, and but just to show that in real time we can make those kind of assessments.
But the
I guess
video
your question
is
is
at the source, right? So then you
yeah,
could get
yeah.
that.
Your question is, there's a reference, right?
Right. What's the reference?
There's a reference that you typically want to go back to.
Right.
And the demo that I showed was not to imply or show any kind of a reference. It was really to show the ability, using leveraging algorithms to basically analyze that content in real time. We made up the score, so it's relative to what we made up, but to show that based on what's happening within that content, what a user would see, how it's impacting those scores. So it was completely not a reference. It was really something that we had put together just to show how the algorithms could work in some of those cases that I had talked about. They're doing things like the blockiness and the blurriness, and in this case here, we're also looking at fast motion detection.
What kind of adjustment can you do?
Okay, so the kinds of things that we could do, the kinds of things that we're working on right now is, and like I said, may not necessarily be, a standalone or closed system. Chances are what would happen is we'd be getting that data back up to higher level systems, which might be doing those adjustments. But the kind of things that you could do are things like, what's my compression rate look like? For certain kinds of errors or quality issues, you may want to either adjust up or adjust down the compression ratios. What about the perceptual quantization ratios that we have built into the algorithms? That's another case where we might want to adjust those up or adjust those down. Might be something as simple as I need more bandwidth. Turn it up, turn it down, that kind of thing. Also, from a service provider perspective, you could look at it as the flip side. I'm kind of painting the negative part of this, saying the quality is not good enough, so we need to make it better. From a service provider perspective, this might be some kind of a tiered service. Let's say you're watching video on your handset, and because bandwidth is always a scarce and expensive resource, right? Regardless of how big the pipes are. What could happen is maybe the quality is better than what this specific service needs. And in that case, maybe we dial down the bandwidth a little bit. So it could go either way, but it's those kind of things. You're looking at some of the compression parameters as well as looking at some of the network parameters.
Does it cover .264?
Excuse me?
Does it cover the H.264?
Yeah. So what we're doing right now is we have techniques that are looking into the bit stream. As we do this, as we make these assessments, the work that we're doing right now just so happens to be around H.264. So if you look at this demo, that was H.264. If you look at what we're working on here, that's H.264. Obviously, when we do this, we need to be agnostic to H.263. It could be maybe some proprietary codecs, whatever whatever that turns out to be. We would look to be agnostic there, not so much worried about what's the protocol, what's the standard that we're following. But we just so happen to be working with H.264 right now. Yeah.
How long does it take? How long does it take to actually make the adjustments and the corrections?
Okay.
From the time you notice it until
okay.
It's
So
visible on my hand.
So let me tell you where we're at, and I'll tell you at least what some other people are doing. So right now this is a prototype that we're building out. Our goal is to be able to do this in real time. Okay. Now, whether the degree of latency that you have there, that's a question that we haven't figured out yet. But I can tell you the goal is to do that. Now, we're not the only company, by the way, that's thinking about these kind of things and employing these kind of things. There's companies that are looking at this, smaller companies. Even some of the larger companies are looking at quality of experience for video, okay, and recognizing that this is important, right? This is an important parameter that we need to manage. And like I said, it doesn't always have to be the best. What it has to be is it has to meet the expectations for certain services, for certain kind of users. But other companies that are doing things like this, if you look at Cisco, if you read some of the Cisco nomenclature, or even look at Juniper, what they're doing. Right now, I know Juniper because we're working with a company that's working with them, is actually planning to put QoE agents in all their routers. Cisco has, is planning to do the same thing. So this is not something that's pie in the sky that is going to be a one-off, but this is something that I believe is going to become pretty standard across the industry, probably in the next 2 years or so. Let's say
Are you embedding something in the signal that is reading the different parameters, or you're actually trying to read the video itself?
What we're doing is we're looking at this. So what we're doing is we have agents. And this is the part I'll be a little bit fuzzy around because we're doing some work that we think might be interesting from an intellectual property perspective. So we have agents that will basically be looking into the bit stream and basically monitoring that data as it's going through. And there's a couple different ways that we're looking at doing it. One is looking at decoded data, which is a little bit more intensive but an easier approach. And there's also an approach that we're looking at right now, which we think might be novel, which is actually looking into the compressed data.
Joe, if I could interrupt for a
Sure.
second, I just want to let everybody know the keynote is starting in a few minutes. So if you want to leave, then this is the time to do so to make sure that you get over there. But we have time in the room here.
Okay, absolutely. I'll stay as long as you'd like to stay.
So if anybody wants to stay here and Pepper Joe some more
Yes, I will,
questions, go
yeah.
ahead.
Okay.
If not, the keynote starts in the lunchroom, and we are back here at 1:10 p.m. for a panel on developer ecosystem. So thanks. Quick.
I was wondering, of all the laundry list of DOEs that you were,
Parameters that we're looking at?
parameters
Yeah.
that you were looking at, what are the top three that you think would be most?
From a satisfaction perspective, one of the big ones that we're seeing is kind of a recurring theme. It's not completely video related, but it's actually the synchronization of the audio and the video.
Okay.
Things like lip sync. That's big.
Right.
Things like if you get blackout, obviously, that's a bad thing. You don't want that to happen. If you're looking at freeze, that's obviously a bad thing. Some of the other things which may not be as bad but are dissatisfiers get into blockiness, macro blocking, blurriness, things like that. Hi.
Are you involved with the IIF standardization that we're
Getting involved. Actually, just hired someone who has worked those kind of things at another company that's maybe part of the role. By the way, I'm Joe. I used to know you way back then,
Okay.
from Jeff Fulmer days.
Oh, okay.
Nice to meet you. Thanks for helping me. Okay, I'll do the same. Any other questions on it? Sorry.
Probably gets into the
Want to talk about this stuff more? If you have other questions, just shoot me. Where do you work?